This video is going to go over 4.3f, which is solving quadratics using any method you want. So if you look over here, there's really only four options that you have. You can complete the square, you can solve by square rooting, you can factor, or you can run the quadratic formula. In terms of my preference, quadratic formula will do every single one of these, but I really like factoring. Having said that, I'm going to use square roots when I can. I probably won't solve any of these by completing the square. I think it's a waste of time and there's more places where you can mess it up. So look, if it has three things, see how these have three ABCs? If that's the case, I'm going to try to factor it as a trinomial. And if that doesn't work, then I'm going to run the quadratic formula. If it has two things, this has two, this one kind of technically has two. That's when I'm going to square root it. And then if it's like a cube down here, I'm going to have to factor that one. So let me show you how I do some of these. First thing I'd do, if it had three things, I would probably do the discriminant, which is this b squared minus 4ac part. So that would look like this. B squared minus 4 times a times c. That's going to be 16 minus 8, which is 8. The fact that this number is not a perfect square tells me that I cannot factor this. And I'm going to have to run the quadratic formula on it. So I would run the quadratic formula, which would look like this. 4 plus or minus the square root of. This number is what goes in the square root part. So you don't have to solve that again. Just put root 8. Then it's all over 2a, which is 2 times 1, which is just 2. Root 8 breaks down to be root 4 times root 2, which is 2 root 2. So this one's going to look like x equals 4 plus or minus 2 root 2 over 2. And I'm basically done. The only thing is you have to reduce these three numbers, divide them all by 2. So I'm going to get x equals 2 plus or minus 1 root 2, or just root 2. And it's all over 1, so you can just leave it like this. Okay, let me show you another. This one right here, you need to realize that's a difference of squares. All these numbers are perfect squares, and it's a minus in the middle. It means you can factor this real easily, just like this. 2x plus 3, 2x minus 3. Now you can set these things equal to 0 and get your answers. That's probably how I would have done this one. Now, you could have also done it by square rooting. So like move the minus 9, divide by 4, and then root it. When you root a fraction, the top gets rooted and the bottom gets rooted. So it's like root 9 over root 4, which is just 3 halves. Just don't forget your plus minus. That's an acceptable way of solving this one as well. Okay, this next one has three things. So I'm going to run the discriminant, do the b squared minus 4ac part. So I almost messed up there. Just be careful when you do the discriminant. Don't miss any negative signs. It's a minus 42 at the end. So that's 121 plus 168, which is 289, which is a perfect square. So that's 17 times 17. So that tells me I can factor this as a trinomial. I need two numbers that multiply to be negative 42 and add to be 11. So this combo is going to be 3 and 14. Took me a second there. So it's going to be -3 and +14. That's kind of a difficult combo to see there, not going to lie. All right, put them over your a value, which was 1. And so it just turns into x minus 3, x plus 14. Set each of those equal to 0 and get your answer of 3 and -14. Okay, this next one, I'm going to run the discriminant on it. So that's the b squared minus 4ac part. So that's going to be 36 minus 84. This is going to give me a negative number, -48. That means I'm going to have a negative in my square root here. So the fact that it's not a nice perfect square and it's not a positive number means I'm going to run the quadratic formula on this problem. So it's going to look like this. -b plus or minus the square root of, remember, you don't need to run that discriminant again. You already have that answer, -48. And it's all over 2a, which is 2 times 1. Root -48 breaks down. Take the I out. And then this is root 16 times root 3. So this turns into 4i root 3. So my answer is going to look like x equals -6 plus minus 4i root 3, and it's all over 2. And kind of like the previous one that we did up here, I have to reduce these numbers. So these are all divisible by 2. So my answer here would be x equals -3 plus minus 2i root 3, and it's all over 1, so you can just leave it like that. Okay, this next one, I would run the discriminant, because my goal is to try to factor it since it has 3 things. But go ahead and run the discriminant. That's going to look like b squared minus 4 times a times c, which is going to be 4 plus, let's see, that's 96, which is 100. 100 is a nice perfect square. So I know this factors. So this is when you do the rainbow and you find your combo that multiplies to be -24 and adds to be +2. That's going to be +6 and -4 are the 2 numbers that you're looking for. Put them over your a value of 3. You must reduce, so this becomes 2 over 1. Then you write bottom x top, bottom x top. And you set each of these equal to 0. So it's like x plus 2 equals 0. So x equals -2 is one of my answers. And then it's like 3x minus 4 equals 0. So you add 4, divide by 3. X equals 4/3 is my other answer. Okay, this next one has 3 things. So I'm going to try the discriminant and see if it gives me a nice perfect square. So that's going to look like b squared, -8 squared, minus 4 times a times c. So that's 64 minus 24, which is 40. That is not a nice perfect square. So I'm going to continue running the rest of the quadratic formula on it. So it's going to look like x equals -b plus minus root 40 all over 2 times 3 is 6, 2a. Here's your a, so it's 2 times 3, which makes 6. Root 40 breaks down. It's root 4 root 10. So that's 2 root 10. So this is actually x equals -8 plus or minus 2 root 10 over 6. And then again, I have to reduce all of these numbers because they're all divisible by 2. So divide them all by 2. And you get your answer of x equals -4 plus or minus 1 root 10, or you can just put root 10 over 3. Okay, now we get to one that only has 2 things, x squared and 48. When this happens, I'm probably going to solve it by square rooting. You could still run the quadratic formula on it if you just put like 0x in the middle. So 0 would be your b term, but I would just solve it by subtracting 48, rooting it, and breaking down root -48. Root -48, I was about to do it again. It's right above there. So that's how you break down root -48. So my answer here would be x equals plus minus 4i root 3. Okay, this next one, this does not equal 0. So that's a problem for me. Honestly, if it just says 2x squared plus 5, I'm probably going to solve it by square root. That's like it's like the previous problem, just with one extra step. So I would start out by subtracting 5. So now I would have 2x squared equals 90. I would then divide by 2, so I'd get x squared equals 45. Then I would root it, x equals plus minus root 45. Root 45 breaks down. That's 9 times 5, so it's root 9 times root 5, which is 3 root 5. So my answer here would be x equals plus minus 3 root 5. Okay, this next one, I would solve this by square rooting it. Because this, I don't care what's inside, it basically has something squared by itself already. So all you have to do is square root this right from the start. So now it's just x minus 7 on that side. That's plus minus root 81. Square root of 81 is 9. So it's like x minus 7 equals plus minus 9. This is when you just go write it twice. Once where it equals positive 9, once where it equals negative 9, then just add 7. So I'd get 16, and I would get -2. And then this last problem is kind of different. It's a cube, but they're just trying to trick you a little bit. Really, you can GCF an x out. Now it's just x squared minus 16. This is a difference of squares. Kind of like that one, problem number 2 up here was a difference of squares. Same principle. So this one, you've got your x in front. Do your difference of squares. So it becomes x plus 4, x minus 4, and all this equals to 0. Then just go set each factor equal to 0 and solve it like this. Again, if you're not sure which one to use, the quadratic formula works for every single one of these. So you might just stick with that one if you're not any good at factoring or solving by square root. But you're definitely, whichever one you run, you're definitely going to have to be able to break down roots. So keep that in mind. Hope this video helped.